Good afternoon, everyone. Myself, Mr. Ashish Kumar Singh, Assistant Professor in the Department of Mechanical Engineering, IIMT College of Engineering, Noida. I am here to present a lecture on the warm topic of present scenario, which is electric vehicles. As we know, electric vehicles are gaining traction and popularity as people became more environmentally conscious. For consumers, there are more EV options are available in the market. On the other hand, more and more automotive companies are also investing in electric vehicle research and development to cope up with this growing trend. But what is an electric vehicles? How do they work? This video will answer all the basic questions about electric vehicles. We will start by explaining what an electric vehicles and how it works. Then we will discuss the different type of electric vehicles available in the market. In this video lecture, we have to discuss four important points regarding electric vehicles. The first is the introductory part, which will tell us what is the electric vehicles, introduction to electric vehicles. In second part, types of electric vehicles available in the market. And in third part, necessary component required for electric vehicle and its function. And in last, we will discuss the benefits of the electric vehicle in India. An electric vehicle is the vehicle that uses one or more electric motor, and this electric motor we can combine with or without an IC engine for the purpose of the propulsion. The main source required to run electric motor is electric energy or electricity. This electricity used to run motor we can get through the different sources, such as in the case of the electric locomotive and metro trains, we can get this electricity through the transmission wires. In the case of the electric bike and electric cars, we can get through a single or a series of connected batteries. And this electricity can also be generated on board using a fuel cell, such as in the case of the hydrogen cars. There are basically four types of electric vehicle available in the market. First one is a battery electric vehicle. Second one is hybrid electric vehicle. Third one is plug-in hybrid electric vehicles. And fourth one is fuel cell electric vehicles. We will discuss all the category and types of electric vehicles in the upcoming slides. The first one, the first type of electric vehicle is battery electric vehicle, and that is the most important type of the electric vehicles. Battery electric vehicles is a pure electric vehicle and it is fully powered by electricity. It is also known as the fully electric vehicle or all electric vehicle. In short form, it is also known as the BEVs. And this BEVs use electric motor and motor controller instead of internal combustion engine for the purpose of the propulsion. These are more efficient as compared to hybrid and plug-in hybrid vehicles. In a figure, you can see here we have the battery pack to store the electricity in the battery. We do not have the fuel tank in this type of electric vehicles. We have an electric motor, and this electric motor will run entirely through the electricity. The battery pack we can charge from the outside. It means we can say in a battery electric vehicle we will not use the IC engine. We will use only the electric motor and which will run through the electricities. Electric vehicle using BEV technology run entirely on a battery powered electric drivetrain. The electricity used to drive the vehicle is stored in large battery pack which can be charged by plugging into the electricity grid. The charged battery pack then provides power to one or more electric motor to run the electric car. There are various components of BEV, such as we have a battery pack which is used to store the electricity in the form of the DC. We have the electric motor. We use the electric motor to convert the electrical energy into the form of the kinetic energy. We have the inverter. Inverter will convert DC electricity into the form of the AC electricity and vice versa. We have a control module which will regulate and control the flow of the electricity. We have a drivetrain, we have a charge port, and we have another also component that is known as the transmission system. The power for the electric motor is converted from the DC to AC with the help of the inverter. As the accelerator is pressed, a signal is sent to the controller. The controller adjusts the speed of the vehicle by changing the frequency of the AC power from the inverter to the motor. The motor then connects and leads to the turning of vehicle wheel through the cogs. If the brakes are pressed or the electric car is decelerating, the motor becomes an alternator, or it will work as a generator and produce the power. And this power in the form of the electrical energy will store into the battery. It is sent back to the battery. This phenomena to charge the battery through the decelerating of the vehicle is known as the regenerative braking. There are various cars available on the technology of BEV, such as we have MG ZS, Tata Nexon, Tata Tigor, Mahindra E20 Plus, Hyundai Kona, and Mahindra Verito. Next one is hybrid electric vehicles. After BEV, we will discuss the HEV. HEV is the hybrid electric vehicles, and it is powered by an internal combustion engine in combination with one or more electric motor that use energy stored in the batteries. HEVs has combined benefits of high fuel economy and low tailpipe emissions. HEVs has both engine and electric motor. The engine gets energy from the fuel and the motor gets electricity from the batteries. The transmission is rotated simultaneously by both engine and electric motor. This then drives the wheel. An HEV cannot plug in to outboard sources of electricity to charge the battery. Instead of this, vehicle uses regenerative braking and the internal combustion engine to charge. The vehicle captures energy normally lost during braking by using the electric motor as a generator and storing the captured energy into the battery into the form of the direct current. As we can see in the figure, we have a fuel tank. This is a fuel tank. Nearby this, we have a battery packs. We have the electric motor in the vehicle, and we also have the IC engine. Basically, these are the small pack battery, and it cannot be charged from the outside. So we do not have any kind of the electricity grid. In BEVs, we do not have any kind of IC engine and fuel tank, but in the case of the HEV, we have both electric motor as well as the IC engine. But in that case, we cannot charge the battery pack from the outside. There are two kind of electric vehicle available in the market according to the fuel efficient system design. The first one is mild hybrid and second one is fully hybrid. Mild hybrids, it is also known as the micro hybrids. use a battery and electric motor to help power the vehicle and can allow the engine to shut off when the vehicle stops, such as when we are at the traffic lights or we are in the stop mode and go on traffics. So we can use that kind of facilities. Further improving fuel economy, mild hybrid system cannot power the vehicle using electricity alone. These vehicles generally cost less than the fully hybrids but provide less fuel economy benefits than full hybrids. Full hybrids have larger batteries and more powerful electric motor, which can power the vehicle for short distance and at low speeds. These vehicles cost more than mild hybrids but provides better fuel economy benefits. There are various cars or automotive vehicle available in the market on the basis of this technology, such as we have some examples: Toyota Prius, Urban Cruiser Hyrider, Honda City EHEV, Toyota Innova Hi-Cross, Maruti Suzuki Grand Vitara, and MG Hector. The next category of electric vehicle is plug-in hybrid electric vehicle. Plug-in hybrid electric vehicles use battery to power an electric motor as well as another fuel such as gasoline or diesel to power an internal combustion engine or other propulsion sources. PHEVs can charge their batteries through charging equipment, or we can say it can charge externally and also can charged by regenerative braking. So this kind of plug-in hybrid electric vehicle has the facility to charge the battery from the outside. In a figure, we can see we have the battery pack, and basically these are the large battery packs, and these large battery packs you have a facility to charge from the outside electricity grid. In the case of the normal hybrid electric vehicle, we do not have any kind of facility to charge the battery pack from the outside electricity grid. We have the fuel tank. We can refill the fuel tank through the fuel, and we have the electric motor as well as we have the IC engine. So this kind of electric vehicle can run on both. In all electric mode it can also run, as well as in a hybrid mode it can also run. There are various components available in the plug-in hybrid vehicles, such as we have a internal combustion engine, we have a electric motor, we have a battery pack, and basically these are the larger battery pack. We have an inverter, control module or controller, we have a drivetrain, fuel tank, charge port, exhaust system, etc. Basically, PHEVs can run in two modes. The first one is the all-electric mode, in which the motor and battery provide all the car's energy. We will not use the IC engine to provide the energy to the car in the all-electric mode. In hybrid mode, and this is the mode in which both electricity and petrol/diesels are employed. PHEVs start up in all-electric mode initially and make use of electricity until their battery pack is depleted or drained. Once the battery gets drained, the engine takes over and the vehicle operates as a conventional non-plug-in hybrid. PHEVs can be charged by plugging into an outside electric power source, engine, or regenerative braking. When brakes are applied, the electric motor acts as a generator, using the energy to charge the battery. The engine's power is supplemented by the electric motor. As a result, a smaller engine can be used, increasing the car's fuel efficiency without compromising performance. There are various cars available on the basis of this technology, and such as we have Volvo XC90, we have BMW 7 Series, Porsche Shiny, Toyota RAV4. So there are various cars available in the market on this technology. But due to hybrid technology, this is the very costly technology, and the purchasing cost of the cars is very high. The next category of the electric vehicle is the fuel cell electric vehicle. In short form, it is known as the FCEV, and FCV EVs are also known as the zero emission vehicles. These are advanced electric vehicles which are powered by energy obtained from the fuel cell instead of the battery. The fuel cell generates electric energy by converting chemical energy of a fuel such as hydrogen. The FCEV generates the electricity required to run this vehicle on the vehicle itself. There are various components we have for a FCEV, such as we have a battery pack to store the electric energy. We have the electric motor, inverter, control module or controller, drivetrain. We should have the fuel cell stack, and it will convert the energy from the hydrogen fuel to the electrical energy. And we also have the hydrogen tank. FCEVs require hydrogen fuel to be stored in a fuel tank. The hydrogen fuel is converted into electricity through the fuel cell stack and charge the battery pack. The battery pack powers one or more electric motors to propel the vehicle. In figure, we can see we have the electric motor, we have the battery to store the electric energy into the form of the DC. We have a fuel cell stack and we have a hydrogen tank. This fuel cell stack will liberate the chemical energy from the hydrogen fuel, and it will convert this chemical energy into the form of the electrical energy and will store this electrical energy in the form of the DC power in a battery. When required, PCU will release the electrical energy from the battery, and this power will go to the electric motor and our vehicle will propel. There are various cars available on these technologies. Basically, it is out of India, and we have Toyota Mirai, Reverse Simple Raza, Hyundai Tucson's FCEV, Honda Clarity Fuel Cell, and Hyundai Nexo. Very costly technology this is. The next part of our this video lecture is to discuss the component of an electric vehicle. So in a figure you can see a car, and there are various components which involved in an electric vehicle. You can see here we have an electric traction motor, and this electric traction motor will convert electric energy into the form of the kinetic energy. We have a power electronics controller, and basically it is a mind of electric vehicle. It will control each and everything. We have a DC oblique DC converter which convert DC power supply, high voltage DC power supply to low voltage DC power supply. We have a thermal system for the cooling purpose. We have a auxiliary battery to run the accessories of the vehicle. We have a onboard charger. We have a transmission system. We have a charge port, and we have a traction battery pack. You can see here we have a traction battery pack. In upcoming slides we will discuss all of them. The first component of the electric vehicle is a traction battery pack. The function of the traction battery pack in an electric car to store the electric energy in the form of the direct current electricity. If it's get a signal from the controller, the battery will flow DC electric energy to the inverter to then be used to drive the motor. The type of battery used is a rechargeable battery and that is arranged in a series manner to create a pack. That is called a traction battery pack. There are various types of electric car battery. The most widely we are using at the time the lithium ion batteries. Next component is DC to DC converter. This one of electric car parts that to convert higher voltage DC power supply to the lower voltage DC power needed to run vehicles, accessories and recharge the auxiliaries battery. The next component of the electric vehicle is electric traction motor and it is the main component of electric vehicle. The motor converts the electric energy into the form of the kinetic energy. This energy rotates the wheels. Electric motor is the main component that differentiates an electric car from conventional cars. An important feature of an electric motor is the regenerative braking mechanism. This mechanism slows down the vehicles by converting its kinetic energy into the other form and storing it for the future use. There are basically two types of motor we can use, that is a DC and AC motor. The next component is the power inverter. The power inverter basically is used to convert or change the direct current on the battery into the alternating current and then this alternating current is used by an electric motor. As we are using the inverter in houses also and the purpose of these inverter also to convert the DC power to AC power and then AC power to DC power. Another component is the charge port and this charge port basically allows the vehicle to connect to an external power supply in order to charge the traction battery pack. Next one is the controller. The controller controls the regulation of electrical energy from the batteries to the electric motor. When you will accelerate the pedal, the signal will send to the controller. Controller will receive the signal and according to this it will act and it will release the electrical energy from the battery. So we can say the controller is the mind of the electric vehicle. Next component is the auxiliary batteries. Apart from the battery traction battery pack, we also have the auxiliary batteries inside the car and this auxiliary battery is basically used to run the accessories of the electrical vehicles. The auxiliary batteries will continue to charge the car. The next one is the thermal system. The thermal management system is responsible for maintaining and operating temperature for the main components of an electrical vehicle such as electric motor and controller etc. And if we are running an electric vehicle, we have to maintain a temperature of the electric vehicle. So we can continuous monitor the temperature of the electric vehicle and its component through a thermal system. Transmission system is the another component of the electric vehicle. It is an important system which is involved in an electric vehicle. We have the mechanical power at the end of the electric motor and if we want to transfer this mechanical power from the electric motor to the wheel, we have to use the transmission system. It is used to transfer the mechanical power from the electric motor to the wheels through a gearbox. The advantage of electric car is that they do not require multi-speed transmission. The transmission efficiency should be high to avoid the power loss. The next part of this video lecture is the advantages or benefits of electrical vehicles in India. So there are various advantages or benefits of electrical vehicles which we will discuss in a current slide. The first advantage, and this is a most important advantage, that is a lower running costs. Since you are not paying for petrol or diesel to keep your EVs running, you save a lot of money on fuel. The cost to charge an electric vehicle compared to the price of petrol or diesel is substantially low. You can reduce the electricity cost further by utilizing renewable energy sources such as solar. The second advantage of electric vehicles is the low maintenance costs. So all of us, basically we are attracting toward the electric vehicle because it's have very low maintenance costs. Petrol or diesel powered vehicles require regular maintenance since they have multiple moving parts. In the case of the electrical vehicle, there are not much moving parts. The electrical vehicles, since they have comparatively lesser moving part, this means that your electric car is likely to have lower maintenance cost into the long run. The next advantage is the better performance. In the past, EVs were seen as impractical. However, that has changed over the years with manufacturers offering well-designed and good-looking EVs. Even the performance of EVs has changed for the betterment. Electrical vehicles are lighter in weight and their acceleration is impeccable compared to fuel-powered vehicles. The next one is the zero tailpipe emissions, and this is most important for the human being and as well as for the global scenario. One of the most significant advantages of EVs is their impact on our environment. Pure EVs have zero tailpipe emissions, which reduces air pollutions. Since the electric motor of the EV operates on a closed circuit, it does not emit any harmful gases. Pure electric cars do not require petrol or diesel, which is excellent for the environment. The next one is the benefit of electrical vehicle is easy to drive and quiet. With lesser moving part and uncomplicated controls, EVs are easy to drive. Also, you can plug such a vehicle into a public or home charging station when you want to charge. They are also quiet, thereby reducing the sound levels that fuel-powered vehicles generate. And the last one, advantage and benefits of the electric vehicle, is the convenience of charging at home. There is no need to find the nearest petrol station to fill fuel. Charge your EVs at home and get moving. With new age charging technology, you can charge an EV quickly or even take advantage of battery swapping services to keep driving without worrying about the availability of conventional fuel. So there are lot of advantages and benefits of the electrical vehicles. If we compare these vehicles with the conventional vehicle, that is the IC engine, petrol vehicle and diesel vehicles. So that was all about the some basic concepts regarding the electric vehicle, and I hope that you all get some knowledge about the electric vehicle. So I want to say to thank to all of you. Thank you very much. Thank you.